All right, let's go ahead and get started. I do want to welcome you back to Unit 5. This is chemical bonding, and this is the fourth screencast for this unit. So last time we were looking at covalently bonded compounds and how they were structured. Okay, so we were looking at molecules, and we took a look at the ammonia molecule. I want to redo that one just to reiterate that and make it a little bit more clear of the procedure. So what we said was that, for example, for ammonia, we're going to look at the individual atoms that are involved. In this case, it's nitrogen and hydrogen, right? So let me write the Lewis structures for each one of those. Nitrogen has 1, 2, 3, 4, 5 valence electrons because it's in the 15th column. And hydrogen has only one valence electron. It's in the first column, but there are 3 of them. So I'm going to say 3 times 1 is going to be 3 for the hydrogen, and again, 5 for the nitrogen. When I add those up, that's 8 electrons. So I need a structure that has 8 valence electrons showing. What I'm going to do is I'm going to place nitrogen in the middle because nitrogen, well, hydrogen can never be in the middle, right? So that's there by default. Nitrogen must be in the middle. Hydrogen then is going to surround as best I can do that. I'll do it as symmetrically as I can, just like that. All right. So by the way, I could have put this H that's on bottom on top just as easily, right? But I'm going to put it right there on the bottom. So that's nitrogen and 3 hydrogens. I need to now place 8 electrons. Let me put 2 here, 2 here, and 2 there. That's a total of 6 valence electrons. Well, where do I put the other 2? Well, remember that hydrogen only wants 2 electrons. So I'm going to put those 2 electrons right there, just like that. So those two electrons are what we call a lone pair of electrons, right? They are a lone pair of electrons. Now, I could, if I wanted to, I'm not going to do it on the structure, I'll do it in the next couple, but I could, if I wanted to, replace these bonded pairs with little dashes, right? I could easily do that. So let's go to the next one, and we'll do it on the next one. So we have water, H2O. We've already looked at this one, but we'll take another shot at it. We've got hydrogen, just like that, a lone pair of electrons, just like that, and there are 2 of them. So we say 2 times 1 valence electron, that's 2 electrons for the hydrogen alone. And then oxygen, again, there's only 1 of them, but it has 6 valence electrons, 2, 4, 6, just like that. So that's 2 plus 6, that's 8 electrons, right? That's a total of 8 electrons, just like that. So let's place those electrons. Well, first of all, I'm going to tell you that for reasons that I'll talk about later, this is not a linear molecule. So I'm not going to put that H right there. I'm going to put it down here. I'll talk about later about why I do that when we talk about molecular geometry and molecular orbitals. But for right now, you're going to take my word for it that hydrogen is kind of off to the side like that. So what I'm going to do is I'm going to put 2 electrons right there, 2 of the 8 there, 2 right there. I've got 2 remaining. I'm going to put 2 there. I have 4 remaining, I'm sorry, 2 pairs remaining, and 2 there, just like that. And that's my structure. Let me add everything up. So I've got 2, 4, 6, 8 electrons total, 2 hydrogens, 1 oxygen. That's my structure for water. And while I'm at it, that's really going to help me on the next one as well, because remember that sulfur is just in the same column as its oxygen, right? Sulfur also has 6, so I can just repeat for H2S as opposed to H2O. I can just repeat that. It's going to be, oops, let's put that S in there instead of the O. Let's replace that with a S, with a sulfur, just like that. And so I'll have 2 there, 2 there, and then I'm going to have another hydrogen down here, just like that. So that would be the structure for H2S. And finally, CCl4. Carbon has 4 valence electrons. Let me write those in. 1, 2, 3, 4. There's 1 of them. And chlorine has 7. 1, 2, 3, 4, 5, 6, 7. And there's 4 of those. CCl4, there's 4 of those. So that's a total of 4 times 7. That's 28 plus 4 more. That's 32. Let me draw those in. I'll put carbon in the middle. And chlorine here, chlorine here, chlorine here, and chlorine there, just like that, right? So 4 chlorines surrounding the carbon, and now what I'm going to do is I'm going to draw in my 32 electrons. I'll put 2 here, 2 here, 2 there, and 2 there. So of the 32, 8 are gone. 2, 4, 6, 8 are gone. Now I'm going to put in 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And that's my structure, my molecular structure for CCl4 carbon tetrachloride, just like that. All right, let's talk a little bit about multiple covalent bonds, okay? Because sometimes you're not going to have single bonds between atoms. You're going to have multiple bonds for atoms such as carbon, nitrogen, and oxygen, right? All right, so let's talk a little bit about how we do that. A double bond or simply a covalent bond or simply a double bond is a covalent bond produced by the sharing of 2 pairs of electrons between 2 atoms. 2 or more, I should say. So let's try this one. This was called methanol, also known as formaldehyde. And what we want to do is do exactly the same procedure, but you're going to find that when we require a double bond, there's something's going to happen that's going to signal you that you're going to need a double or maybe even a triple bond. What is it? Well, let's follow exactly the same procedure as I've said. 1, 2, 3, 4. That's carbon right there. That's a total of 4 electrons, just like that. Hydrogen is going to have 1 electron, but there's 1 valence electron, but there's 2 of them, right? There's 2. Let me do that a little bit neater. I know better than that. All right. Here we go. All right, there we go. So now I've got hydrogen, but there's 2 of them. So I'm going to say 2 times. So that's going to be 2 more electrons. And oxygen, of course, it's in the 16th column, 2, 4, 6, 8, 2, 4, 5, 6 electrons. That's a total of 6 for the oxygen, so 6 plus 4 is 10. 12 electrons is what we've got to work with, right? 12 electrons total. Let's put them in. So I've got carbon, hydrogen twice, and oxygen. Carbon always goes into the middle. Oxygen goes up here. I'm going to make this as symmetrical as I can, okay? Just like that. Now let me put my 12 electrons in, but watch what's going to happen. Watch what's going to signal me that I need a double bond. Watch. 2, 4, 6, 8, 10, 12. But this carbon doesn't have enough electrons, right? That's it. That's the signal that tells you you need to try a double bond. If you run out of electrons, you have 12. If you run out of electrons, that's your signal to try a multiple bond. You might even have to try a triple bond. Let's erase that and try this again. Remember, I have a total of 12 electrons to work with. Let me make the structure itself the same. Carbon here, oxygen there. I'll put a hydrogen right there and a hydrogen right there, just like that. Okay? So here we go. 12 electrons. This time, I'm going to put a double bond right there. Okay? I'm going to do it with 2 little lines. There's 4 electrons there now. I'm going to put a line here, a line here. I've taken care of 8 of the 12 electrons. 2, 4, 6, 8 of the electrons. But where do the other 4 go? Right here. 2 and 2, right? Okay, let's check to see if this is going to work. Remember, I have to have a total of 8 electrons. Let's count. 2, 4, 6, 8, 10, 12. That's good, right? Now, does every atom other than hydrogen, who's only requiring 2, have 8 electrons? Well, this hydrogen has 2, this hydrogen has 2. How about this carbon? 2, 4, 6, 8. Good. How about this oxygen? 2, 4, 6, 8. We're in business. That's it. That's the structure. That's formaldehyde or methanol, all right? We've just done our first structure with a double bond, all right? With a double bond. All right. Draw the Lewis structure for, folks, this is a typo, my fault. It should be watch this, ethyne with a Y, just like that. E-T-H-Y-N-E, change that in your notes. Change that in your notes. Okay, so here we go. Carbon has 4 electrons, valence, 1, 2, 3, 4, right? and there's 2 of them. So 2 times 4 is 8, just like that. Hydrogen has 2 electrons. Also, has 1 valence electron. 2 times 1 is 2. That's a total of 10 electrons. All right, let's just check that one more time. It's C2H2, 2 carbons. Each carbon has 4. 2 times 4, 8. That's good. 2 times 1 hydrogen has 1. 2 times 1, 2. 8 plus 2, 10 electrons, right? Let's put them in. I'm going to put a carbon here, a carbon there, a hydrogen there, and a hydrogen right there. So I'll put, let's see, 1, 2, 4, 6, 8, 10. But now this carbon doesn't have enough. Let's try a double bond. Let's try a double bond for this compound called ethine. So I'm going to say carbon here, carbon there, hydrogen there, a hydrogen there. Here we go. 2, 4, 6, 8, 10. Just like that. Now this carbon doesn't have enough. What do I do now? If you still don't have enough, here's what you're going to do. You're going to try a triple bond. It happens. We're going to try a triple bond. So we're going to say carbon, carbon, 1, 2, 3, 3 bonds there. I'll put a hydrogen there, a hydrogen there, a bond there, and a bond there. Let's see. 2, 4, 6, 8, 10. Hey, that's the right number of electrons. Does every atom have 8 other than hydrogen that wants only 2? Well, hydrogen wants 2, it's got 2. Hydrogen wants 2, it's got 2. Carbon, 2, 4, 6, 8. That's good. This carbon, 2, 4, 6, 8. That's it. That's the structure for ethine. That's the structure for ethine. All right? Getting the hang of this? All right. Let's try this one. Let's try nitrogen. Nitrogen, remember, has 5 valence electrons. 1, 2, 3, 4, 5 valence electrons, but there's 2 of them. So that's a total of 10 valence electrons, right? 10 electrons. So there's only 2 nitrogens, so that's going to be pretty straightforward. So we're going to need to put 10 electrons around them. Let's try this. 2, 4, 6, 8, 10. Here's another one with a triple bond, right? Here's another one with a triple bond. Well, you might say, how did you know to put a triple bond there in the first place? Well, experience has shown me that when I try to do it with 10 electrons and I try a single bond, I don't have enough electrons. If I try it with a double bond, I still don't have enough electrons. And so finally I have to try it with if I try it with a double bond, I still don't have enough electrons. So finally I have to try it with a triple bond, and so that is what works. Next, draw the Lewis structure for CO2, carbon dioxide. All right, so we're talking about double bonds here. So carbon has 1, 2, 3, 4 valence electrons, and oxygen has 1, 2, 3, 4, 5, 6 valence electrons, but there's 2 of them. So 2 times 6, 12 electrons, 4, that's a total of 16 electrons, just like that. Here's how I would do it. I'm going to put carbon right in the middle. I'm going to put oxygen right over here and an oxygen right over there. What I'm going to do is I'm going to put double bonds on each side. 2, 4, 6, 8. Now I've got 8 more to go. Where do I put them? Don't put them on the carbon because carbon already has 4. 2, 4, 6, 8, 10, 12, 14, 16 electrons, and there is my structure. Okay, there is my structure. Hydrogen cyanide, this is the last one for this screencast. Hydrogen has 1. Cyanide is C, just like that. Okay, it has 1 carbon, and nitrogen it has 1 carbon with 4 valence electrons, and nitrogen has how many? It has 5. 1, 2, 3, 4, 5. Folks, looks like I'm going to run out of time on this one, so I'm going to go ahead and take care of this one on the next one. I'll see you there. Thanks.